So thank you all for coming, and thank you, Jim, for inviting me down. My name's Stuart. I'm going to introduce you to a concept called railway-oriented programming, which is an approach I've lifted from functional programming. I've got some slides about me, but I'm not important, so let's skip those. This one I can't skip because this is important. I just want to make it clear, I am not a functional programmer. I don't write code in functional languages. I don't write in a functional style whatsoever. There's a few people in the room who do know me, and I imagine one of the reasons they're here is they're wondering what the hell's Stuart doing talking about functional programming, because I really am not a functional programmer. My take on functional programming is it's a programming pattern that suits some people's brains more than others. I first came across it in 91, 92 as part of my degree course. And back then it was very clear that a few people latched onto it and it really suited their way of thinking about a computer. But for the rest of us, especially those of us who were brought up programming CPUs directly in the 80s, where we were programming mostly in machine code, it was an abstraction too far. And it's never stuck with me as for functional programming. So I just want to set the scene there. If anyone's expecting functional programming wizardry, the bar's downstairs. You'll enjoy yourselves there a lot more, okay? So why am I talking about functional programming? The reason is I'm on a quest. When I left DataSift 3 years ago and founded my own company, I realized I had an opportunity to sort of reevaluate how I approach programming. By that point, I'd been programming for over 30 years. And I was a bit unhappy with some of the results, to be honest. And there's three things I'm after. The first thing I'm after, making sure I've got them in the right order, is reusability. I'm very frustrated with how hard it is to take code from one project and reuse it successfully in another. Very frustrated with that. Whilst I was at DataSift, I was involved in open sourcing quite a bit of the software we wrote there. And then I came to apply it to other contexts. And even though it was all packaged up nicely, it was all properly unit tested and all the rest of it, we still couldn't reuse it. And I got very frustrated with that. The second thing is about being able to read code and understand it. So this isn't readability, this is the gap between what you think the code's going to do and what it actually does when it executes. And one of the things we do as a business is we actually go into clients and help them understand what the code is that they've written that it does and help them understand third-party code. So this is something I've got a very vested interest in. And my third one's robustness. My first job in the industry was maintaining code originally written for NASA. This code was called the network queuing system. And back then, there weren't many Unix machines around, and so you rented time on them, and NQS managed those batch jobs. And if NQS crashed, the batch job had to be restarted. And these batch jobs were at universities doing fluid dynamics, they were doing weather forecasting and that sort of thing. And they could be running for months at a time. So if NQS crashed, you could lose up to 2 months of wall clock time. You can never get that back. You have to wait another 2 months for your computation to run. So my first introduction to the industry was very much about you've got to write code that is absolutely bulletproof and zero defect. You can do it, but most people can't afford it. That's the difference. So whilst writing this talk, it occurred to me and it helped me realize that there's three pillars in what I'm doing with my quest to improve my own programming. These three R's. I doubt it will catch on, but you never know. If anyone wants to take a photo and tweet it, please do. Okay. So, sorry. Now, maybe I'm tilting at windmills with this, who knows? I don't think I am, but I'm well aware that a lot of the third-party code I interact with, you don't see any of these attributes, these aspects of that code evident at all in the results. And I'm going to show you partly why as we go through this talk, because I don't think it's the developer's fault necessarily. Which brings us on to functional programming. Why are we looking at it? Especially with PHP. PHP is not a functional language. Anyone who's tried to write emulations of functional approaches in PHP will hopefully have figured that out for themselves. It really isn't a functional language at all. It's very much, especially since the PHP 5 came out, it's very much an OO language. That's very much what the community promotes. It's OO. I've been doing OO commercially since 96, 95, 96. So I've been doing this over 20 years. So I think I'm ready to call this. I don't think OO is about reusability. I don't think it delivers on reusability, and I don't think it ever will. I think it's got inherent problems with that. and I'm going to show you what I mean. I think there's 3 problems with OO code. And what do I mean by that? So just a basic primer for everybody. The concept behind OO is encapsulation. It's to wrap state up so you can't directly manipulate state. You're forced to go through applied logic to manipulate that state. You can't manipulate it directly. That's the idea behind OO. And when OO was first introduced, it was a direct reflex to old C programs where pretty much you can change anything whether you're supposed to or not. Especially on old microprocessors which didn't even have memory protection. Those were the days. But if you take an object, it contains data, which are properties and attributes, and it's got methods. And the idea is you're supposed to call the methods, and those methods go and interact with the data. They're fetching data into its working memory and making changes to that data and then saving it back. And then the method finishes executing. It might return a value, it might be a return void method. That's conceptually how OO is meant to work. But unfortunately, that's not how OO actually works. It's not the whole picture. Because what's actually going on, when we're doing this, sorry, that screen's up there, I'm pointing at my screen, sorry. What's actually happening when we call our method is it's going off and calling methods on other objects. Okay? And they're changing state inside those objects. And so on and so forth. You've got this whole dependency tree. So we think we've got this, and that's what we're seeing, but you can't always see everything else that's going on, especially as we move to a more package-based approach where you're pulling in many tens of thousands of lines of third-party code. Has anyone recently done a line count in their vendor folder to see how big it is?
Simply 4 out of the box, but then start doing a little bit of tinkering with Node, 20,000 lines.
Right.
In Node modules.
Yeah.
You're going to do something else.
Okay, but how big's your vendor folder for Symfony?
Actually, they're getting better.
But the point I'm trying to make here is what this object tree here, this object dependency, is a dependency graph. And what you've actually got is high coupling, but you can't see it. And the thing with high coupling, the reason for decades we've been banging on about high coupling is because of the consequences of high coupling, which means it's very sensitive to change. You change something in one area, you break something somewhere else because they're all interdependent. You might think of them as separate classes and they're instantiated as separate objects, but because they don't work in isolation, they all depend on each other. That change actually propagates through and you get problems. How many times have you upgraded your vendor package, your vendor folder, you've run Composer, and all of a sudden your app stopped working?
Yes, many times.
Yeah, that's exactly what I'm talking about. And when that happens, how quickly do you notice the breakage? Do you notice it straight away?
Very quickly.
Very quickly.
If I'm actively working on a project.
If you're actively working on a project. And if you're not actively working on it?
I will never notice.
Exactly. So,
Depends how good your versioning pins are. Right?
but that also depends on the upstream projects you're consuming, honouring those versioning approaches and honouring Semver properly, doesn't it?
Well, you've got to trust Semver.
Yes.
Giving some credit out.
And how many of them are 100% accurate with Semver?
None.
Exactly. Yeah. And once something breaks, how much time do you spend finding out why it broke? Not actually creating a fix and shipping it, but actually just figuring out what the fix should be, where the fix should be. How long do you spend on that?
Spent half a day yesterday doing something like that.
Half a day?
Oh, bloody hell.
Yep. So that's half, I presume you work in a commercial organisation? Kind of. Okay, so that's half a day of your time that's being billed out for something else. What should be used to ship new things rather than, yeah. That rework is a problem. And I'm not singling out any one programming language, any one package or set of package maintainers, because the reason I was very pleased you mentioned C++. C++ has exactly the same problem. It's a problem inherent in object-oriented programming languages, period. Java's got the same problem. If anyone still uses IFL, it will have the same problem. My IFL is gone. It's so long since I used it, it's completely gone. Now, I'm well aware that some package maintainers, naming no names at all, like to point out how they break their large objects and classes up into smaller ones. Loads of small methods with like 5 to 10 lines, something like that. They can't ship those 5 to 10 lines though. They're still highly coupled. It's how many of you know about microservices? So the old joke with microservices is you take a monolith, you break it up into microservices, all you've got is a distributed monolith. Yeah? Because you've still got to ship the whole thing. You change one microservice, everything else breaks. Because they're not actually doing microservices. They're just putting everything onto different boxes and using it as a distributed monolith. That's the old joke. And it's the same thing with taking large classes, large objects, and just making them lots of smaller methods, and instead of 10 classes, having 100 classes. So this is why I'm talking about a functional approach. OO doesn't have the answers. After 20 years of doing this at quite a high level, OO doesn't have the answers. All it does is move things around so they look different, but it's still the same problems. So I'm taking advantage of the fact that I work for myself, so I don't have a boss telling me what to research. I can research the things I think are important. I'm taking advantage of that to look at the things to help me. Now, all of you in this room are going to be on journeys of your own. There's going to be things you're focusing on that are important to your programming for where you are, your careers, your interests, etc. And they're just as valid as what I'm on. And one of the reasons I come and do these kind of talks is because I want this interaction that I'm getting back from here. Okay? I want to hear your own thoughts and opinions as well, so I can learn while I'm here. All right? Cool.